There's some questions here that I took right from the test. You'll see them cloned. My favorite student is good old Ann, and you're telling me I made a math mistake in the score for this one? So it's not out of 17. We'll come back to that in just a second. I like number one, I like number one, I like number one. Number one is asking you to find how much work to go into orbit. Although I was a bit nice for you here, I calculated the speed for you. Okay. So it wants how much work? That's going to be the change in potential plus the change in kinetic. Why can't, don't write this down, why can't I cross out the change in kinetic? We're in orbit. You have to have some kinetic energy. What I've recommended to you folks is I do these separately. I usually find the change in potential first, which is going to be negative big G, big M, little m, over R final minus negative big G, big M, little m, over R initial. The change in potential is going to be negative 6.67 times 10 to the negative 11. We are on the moon this time. I don't know the numbers for the mass and radius of the moon, so I got to use my sheet. Mass of the moon, 7.35 times 10 to the 22. Mass of the satellite, 1,600. Final radius, they gave me a height, so the final radius is going to be 2 times 10 to the 6th, plus the radius of the moon, which is 1.74 times 10 to the 6th. Then I'm going to have a plus, I'm going to have a ditto mark times a ditto mark times a ditto mark divided by, and we're launching from the surface of the moon, which has a radius of 1.74 times 10 to the 6th. The change in potential is going to be negative 6.67. Let's try that again. Negative 6.67 times 10 to the negative 11 times 7.35 times 10 to the 22 times 1,600 divided by bracket 2 times 10 to the 6th plus 1.74 times 10 to the 6th. I missed a 7. Any other typos? Negative 6.67, 7.32, Mr. Dewick, 7.35, Mr. Dewick, times 10 to the 22, times 1,600. I think I caught all my typos. That was a lot of them. And I'm going to carry 5 sig figs, so negative 2.0973 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that what you got for the first fraction, folks? Yes. Yeah. And then plus, now I get to the less work part. A little easier. I just want to delete that. And I forgot to delete the negative. So let's go times negative 1. There's the answer that I want. 4.508 times 10 to the excuse me, not to the 10th, Mr. Dewick. Read that carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I get a change in potential energy of that number, take away 2.0973 times 10 to the 9th. And I get 2.4107 times 10 to the 9th. Positive 2.4107 times 10 to the 9th joules. There's the change in potential. That's how much energy we need just to lift the rocket up to that height. Now to keep it up there, we need to go into orbit. So the change in kinetic is going to be a half mv final squared minus a half mv initial squared, although we said we'll always assume that we're launching from the North Pole. So it's going to be a half 1,600. Did they give me the speed? If they hadn't, then what? Gravity is what's pulling me in a circle, and I'll find the speed. V orb is square root of big G big M over R, and plug it into here. But since they gave me the speed, 1.145 times 10 to the third. Don't forget the squared. The change in kinetic is I get a change in kinetic of 1.04482. I wrote that down wrong. 1.04882 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 9th. I think we found around Earth most of our answers were in the 10 to the 10th range. Yeah, I guess the moon will be about 10 times easier because it's a little smaller. Fair enough. So these numbers, gut instinct, at least feel right to me. How much work? It's going to be 2.4107 times 10 to the 9th plus 1.04882 times 10 to the 9th. 2.4107 times 10 to the 9th plus, haha, answer button. Do you finally end up with 3.46 times 10 to the 9th? If you got that, this question really should be worth more than 3 marks, but because it's only 3 marks, I'm going to say this. 1 mark if you got that, 1 mark if you got that, 1 mark if you got that, which is really a bad way to mark this, but it's what we got. I don't know of a shorter way to get there. Number 2. Isn't number 2 the same question as number 1? Well, except in number 1, I was nice enough to give you the speed, which made finding the kinetic energy a lot easier. Question number 2. Okay. Whoop. Work. It's going to be the change in potential plus the change in kinetic. We're in orbit, so I don't cross out the change in kinetic. I'll start out finding the change in potential, which is going to be Linden negative big G big M little m over R final minus negative big G big M little m over R initial. Holy smokes, this is going to be negative 6.67 times 10 to the negative 11. Are we back on the Earth? Back on the Earth. 5.98 times 10 to the 24th, 3,200 divided by, this is a radius, so I can just plug in 8.3 times 10 to the 7th, minus minus, which is a plus, ditto mark times ditto mark times ditto mark, divided by 6.38 times 10 to the 6th, negative 6.67, scientific notation, negative 11, times 5.98, scientific notation, 24, times 3,200, divided by 8.3, scientific notation, 7. Double check for typos. Looks right. Did you get negative 1.5378 for the first term? Negative 1 point, what did I say it was? 5378 times 10 to the 10th. 5378 times 10 to the 10th. And then there's going to be a plus sign. And I can delete the negative. I remembered to this time. And then 6.38 times 10 to the 6th. And I get positive 2.00058 times 10 to the 11th. Is that right, folks? So, the change in potential. And this is the longest question of the year. It's going to be that number, take away 1.5378 Scientific notation, 10. And I get 1.8468 times 10, 1.8468 times 10 to the, I think it was 11, Mr. Dewick, times 10 to the 11th. There's my change in potential energy. I'll put units there just for giggles. Change in kinetic energy. How much room we got? Oh, boy. It's going to be a half mv final squared minus a half mv initial squared. What did we say our initial velocity is going to be assumed to be? Okay. Do I know little m? Yeah. Do I know v? Gravity. You know what? I'm going to be really lazy. I'm going to get the v squared by itself, because that lets me replace the v squared with that instead of square rooting and then squaring on my next line anyhow. So I can say the change in kinetic energy. I'm going to need more room, Mr. Duke. The change in kinetic energy is going to be a half. Little m was 3,200. And then I have, oh, this is wrong, by the way. That little m there should have canceled. I wrote v squared equals big G, big M, little m over r. You guys should have been screaming at me because that's not right. That m would have canceled. 6.67 times 10 to the negative 11, 5.98 times 10 to the 24th, assuming we're on the Earth. We are. Divided by, and r was 8.3 times 10 to the 7th. You know, with a bit of cleverness on my calculator, I think I can backspace and see most of these numbers. So there is a 6.37. I think what I need to do in front here is put a half. So there's a half, big M, little m, and it's going to be 8.3, scientific notation button, 7, not squared. I think that's right. A half, check. Big M, little m, big G over R. You got the change in kinetic is 76889. Not, you know what? 76890. Really? No. Yes. 76890. So it's going to be 7.8960 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Final answer. Work is going to be the change in potential, 1.8468 times 10 to the 11th, plus the change in kinetic. Is this right? Is it 10 to the 9th? Okay. Plus 1.8468, scientific notation, 11. You get 1.92 times 10 to the 11th? Whew, that's a lot of work. If you got that right, what was this question out of? Otherwise, 1, 2, 3. If you got that right, 7 out of 7. Otherwise, I'd probably give you 1 mark for that. 1 mark for that. 1 mark for that. That's 3. 1 mark for that. 1 mark for that. 4, 5, 6. I need 1 extra mark to go around. Probably give you 1 mark if I saw that long monstrosity equation. But you got it right, 7 out of 7. What is its escape velocity? So the key idea is that escape velocity should be called escape speed. We solve using conservation of energy, G. Why does it equal 0? Because where do we want to end up? All the way out at infinity, so my potential energy is going to be 0. How fast do we want to be going once we get there? 0. We want to do this so perfectly so that we coast to a stop right at the split second that we're free of the gravitational pull of the planet. So I'm going to get this, a half m v initial squared plus negative big G, big M, little m over r initial. Usually on this line I drop the initials because everything is initial now. I'm going to get a half m v squared equals positive big G, big M, little m over r. We noticed the following. We noticed that. We said, oh, you want to get the v by itself? Can do that. V is going to be the square root of 2 big G, big M over r. Which is going to be the square root of 2 6.67 times 10 to the negative 11. 3.14 times 10 to the 30th. Mitra, you'll notice I did say mass and not weight, just saying. Divided by 2.72 times 10 to the 7th. I have no idea what the escape velocity of this is going to be. 2 times 6.67. Scientific notation. Whoop. Negative 11. Times 3.14. Scientific notation. 30. Divided by 2.72. So Caleb, you're saying that the radius is pi?
No.
Oh, sorry, the mass is pi?
The mass is pi.
What's the radius?
E?
It is E, 2.7182818. And it goes all weird off the screen. Sounds like it's going to repeat, and it doesn't. 2 m little m, sorry, 2 big G m over r, square root of that. You get 3.92 times 10 to the 6th. Pretty fast. It's a pretty big planet. If you got that, 3 out of 3. Otherwise, wow, I made this 4 marks. 1, 2, 3, 4, 5, 6. I'd probably go 1 mark for that. 1 mark for that. 1 mark for that. And 1 mark for the answer. Something like that. Last one. Asteroid impacts. Lena, what's this question asking me to find? Yeah, and I think in this case it'll be a V final. Yes? Is there a change in that? Is it saying how much work? It's meant to be really obvious. Is it asking how much work? So don't be using work equals change of potential plus change of kinetic. Are we in orbit? How do I know I can't be in orbit? Because I'm crashing into the definition of an orbit is you're not hitting the planet. This, you know what? There's a change in height, change in speed, yucky curvy force, conservation of energy, G. Are any of these 0? Kinetic final? You think when you hit the ground you're at rest? Do a belly flop onto the cement. I guarantee your final kinetic energy when you hit the ground is not 0. After you hit the ground? Potential final? Where is 0 when we're talking about potential energy of outer space? Where is it defined at? So are we at infinity? The final? So are any of these 0? No. Okay. So this is going to be half m v initial squared plus negative big G big M little m over r initial. That equals a half m v final squared plus negative big G big M little m over r final. Well, I think, Matt, what do they want me to find here out of all these variables? Yeah. I'm going to plus this to that side. That's going to give me a half little m v initial squared plus negative big G big M little m over r initial plus negative big G big M over r final. That equals a half m v final squared. I could probably do something more with that, but that's good enough for now. Did I make a dumb mistake somewhere?
No, not the M's cancel.
Pardon me?
Did the M's cancel?
They do. I could have gone like this on the previous line, couldn't I have? That would have been clever of me. You know what? Maybe now I will get the V's by itself, because how would I get V final by itself? I've usually avoided it, but Lena, what? You're loud. Say it loud and proud. When I say loud and proud and you get quieter, that's the opposite of loud and proud. I'm going to go times that by 2, by 2, by 2, by 2. There, that cancels. There, that cancels. So I'm going to get VI 1.37 times 10 to the 4th squared. Take away 2, 6.67 times 10 to the negative 11th. Are we around the Earth? 5.98 times 10 to the 24th. Oh, little m canceled. All over, what's our initial radius? It is a radius because it says from the center of the Earth, 2.2 times 10 to the 7th. Then there's going to be a plus, same thing, over 6.38 times 10 to the 6th. What was that? You okay there, Caleb? Oh, and that equals V final squared. That's all that's left on the on the right hand side. Okay. Wow. 1.37 times 10 to the 4th squared. 18769 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 1.8769 times 10 to the 8th minus 2 times 6.67 scientific notation negative 11 times. You guys okay? Can we stop? Thank you. 24 divided by 2.2 scientific notation button 7. You get that for the second one? 2 big M. No, I'm just getting these one term at a time. 3.6261 times 10 to the 1, 2, 3, 4, 5, 6, 7. Plus, same thing, but let's backspace and edit. I think all I need to change is the 6.38 times 10 to the 6th. The 2 stays, that stays. You get positive 1.25036 for that third term. And that's going to be times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. And that equals, I think, just VF squared, right? So, Manir, this is what you've been waiting for. Here we go. It's that takeaway 3.62. Scientific notation button 7. Takeaway 1.8769. Not takeaway, Mr. Dewick. Plus, Mr. Dewick, 1.8769 times 10 to the 8th. Answer button was positive. So positive, take away negative, plus positive. I get, that's the next step, but I'm writing down everything because it's not like I can't make a mistake here. VF squared equals 27653 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 2.7653. Come on. 7653 times 10 to the, what was it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Joules. Now what? Huh. Here we go. 16,629? 16,630? 16,600? $1.66 times 10 to the 4th. So you got?
Yeah.
Whew! It's a lot of work. Here, for 7 marks, oh, I don't know. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. Can you give yourself a lovely score out of 7 plus 4 is 11 plus 7, 11 plus 7, is that a 19? Oh no, there's one more, isn't there?
It's out of 21.
19 plus 22, isn't
That
it?
was 18.
Did I just add wrong? 3, 10, 14, 21. Is that a 21?
Yes.
So all of us were wrong. Sure, I believe you. Whatever you say.
It's recorded. You can go back.
Yeah, go to the recording.